Okay, hello guys. Well, today in this lecture, I am going to start by explaining the concept by which the last lecture was finished, which is the concept of real numbers. Okay, so today I'm going to talk about real numbers. So what do we mean by real numbers? Okay, now I would like to refresh your memory about the types of numbers that we have previously talked about in the last lectures. We have talked about integers, okay, integers, and we said that integers is the set of numbers which contain numbers that do not have decimal points. So the set of all numbers which do not have decimal points are or is called the set of integers, such as 1, 2, 3. Also the negatives of these numbers are integers. -1, -2, -3. 0 is also considered to be an integer. Okay, what other type of numbers that we have covered as well? We have talked about something called the rational numbers. Okay, we have talked about the numbers rational numbers, and we said that these rational numbers are also called in some textbooks as decimals. These numbers are all the numbers that do have decimal points, okay, such as 1.5, 1.2, -1.3. Okay, so all of these numbers which have decimal points in them are called rational numbers. Okay, all right. So the set of real numbers is actually the set which contains both integers and rational numbers. Okay, so both integers and rational numbers are considered to be members of the set of real numbers. Basically, any number, any mathematical number that you can think of is actually a real number. So if you would like to think about the square root, for example, if you would like to, okay, to calculate the square root of any number, the square root of 2, okay, the square root of 2 will give you a rational number. Okay, so it will give you a number that has a decimal point or decimal points in it, 1 point something. All right, so this also is considered, or the square root, okay, the square root is also considered to be a member of the set of real numbers. All right, so any number is considered to be a real number. Okay, what else do we need to know about real numbers? Now about I'm going to explain how we can graphically represent real numbers. Real numbers are sometimes represented by something called the number line, okay, or the horizontal number line, which looks like this. Okay, so we have a horizontal line called a number line. So this is called the number, okay, number line. All right. The number line is actually used to represent the set of all real numbers in mathematics. Now, this horizontal number line has a midpoint which represents the value of 0. So the midpoint of the number line represents the number of 0, which, as I said, is considered to be an integer and also is considered to be a real number. Okay? Now, all the numbers that are located to the right hand side of 0 are greater than 0. So we have, for example, the numbers half, okay, half, 1 point. So we have half, 1.5, 1 point, okay, 1.6, and so on and so forth. We have a 3, we have 4.6, Okay, so all of these numbers, all the real numbers that are greater than 0 are represented on the right hand side of 0 on the number line. Okay, and as you can see here, the number line extends to infinity on either side of 0. So this side is going to extend to positive infinity, and this side is going to, okay, or extends to negative infinity. All right, so this is the number line. The number line is a graphical diagram which is used to represent the set of real numbers. Okay, this is actually all what you need to know about real numbers. Now I'm going to talk about a new concept which is decimals. All right, which is decimals. Okay, so the next thing that we are going to talk about is decimals. What do we mean by a decimal number? Actually, this word, it is not the first time for you to hear about the word decimals. We have actually mentioned the word decimals when we talked about the concept of real number, when we talked about the concept of rational numbers, and we said that any number that has a decimal point is called a rational number and is also called a decimal number. So 1.5 is considered to be a decimal number as well. Okay, what do we need to know about decimal numbers? Suppose that we have a number like this. Okay, so we have, for example, 7. All right, 7, 5, 3, 2. Okay, and we have dot here, 4, 1, 8. Okay, suppose that we have this number. Now, the question is this number considered to be a decimal number or not? Yes. Why? Because this number has a decimal point and we have several numbers located on the right hand side of this decimal point. Okay, so this is considered to be a decimal number. Now, one important thing that you need to know about this number is that this number, okay, can be represented by this mathematical expression. So we have 7. Okay, now the way how we read this number is 7,000. So 7 is actually multiplied by what? Is multiplied by 1,000, right? This is the way how we can write up. Okay, this is a different way how we can write up the value of this number. So 7 is actually multiplied by 1,000. Okay, what else do we say when we read the value of this number? So we have 7,500. Okay, so we need to add up 5 multiplied by 100, right? Okay, how about a 3? How about a 3? Now 3 is actually 30 here because 7,532. So 3 should be multiplied by what? By 10 in order to give us 30. How about 2? 2 is actually multiplied by 1, right? Because 2 is located in the units. Okay, look, 2 is located in the units. How about the dot? How can we write up, or how can we mathematically express the numbers that are located on the right hand side of the decimal point? Now in this case we need, for example, 4. Okay, 4 is actually represented by this mathematical expression. It is 4 multiplied by 10 to the power minus 1, because this is the first number located on the right hand side of the decimal point. The second number located on the right hand side of the decimal point is mathematically expressed as 1 multiplied by 10 to the power minus 2. Okay, because this is the second number. How about 8? Okay, so 8, it is the third number, so it should be multiplied by 10 raised to the power minus 3. Okay, so this is the mathematical expression that can be used in order to calculate or in order to express the value of this decimal number. Okay, now What you need to note here is the following. What is the important thing that we should conclude from this mathematical expression? If we look at the number 1000, 1000 is actually 10 to the power 3, right? So I am going to write it by 10 to the power 3. So here we need to raise 10 to the power 3. How about 100? 100 is actually 10 raised to the power 2, right? Raised to the power 2. 10 is actually the number 10 is actually an exponent which has the power 1, right? How about 1? 1 is actually an exponent which has the power 0. Okay, so we can write up 1, or we can express 1 as an exponent which has the base of 10 and the power of 0, and so on and so forth. So what you need to note here is that 2 is actually multiplied by 10 raised to the power 0. 3 is actually multiplied by 10 raised to the power 1, and so on and so forth. Okay, and 5, 10 to the power 2. 7 is actually 10 to the power 3. So all the numbers that are located on the left hand side of the decimal point are actually, or can be ordered using the list of 0, and you have 1, you have 2, and you have 3, right? Okay, so this is the way how we can order the numbers located on the left hand side of the decimal point, right? So 7 is, in order to express 7, we need to multiply 7 by 10 raised to the power which has the value of the order of 7, alright, which is a 3. 5 should be multiplied by 10 raised to the power that has the value of its order on the decimal point, which is 2. Okay, and so on. Now, how about the numbers located on the right hand side of the decimal point? These numbers are ordered using the list of 1, 2, 3, and so on. So if you look at the number 4, 4 has been multiplied by 10, which is raised to the power minus 1. Okay, so we need to put negative here. Okay, minus 1, minus 2, minus 3, and so on. All right, this is actually what you need to know about decimals. Okay. All right, now let's talk about something called the absolute value. I am going to explain the concept of the absolute value. So we have something called absolute value. All right. What do we mean by the absolute value of a mathematical number x? Suppose that we need to calculate the value of, or the absolute value of, the number x. This is actually the symbol that we use in order to represent the absolute value of a number. Suppose that we have a number x, any number, any real number, whether it is integer, whether it is rational, or any number. Okay, now in order to express the absolute value of this number, we need to put it, okay, to put it inside two parallel vertical lines like this. Okay, so this is the expression that we use to represent the absolute value of a mathematical number. Okay, how is the absolute value defined? The absolute value of the number x is actually defined as, okay, is actually defined as x, okay, x if the value of x is greater than or equal to 0. So if x is greater than or equal to 0, the absolute value of this x is the same as x. And we are going to give several examples now. Okay, how about if x has a value that is less than 0? Okay, the absolute value in this case is going to be minus x. So minus x if, okay, if x is less than 0. This is the mathematical definition of the absolute value. Let's give an example. Suppose that we would like to calculate the absolute value of 5. Okay, now the question is 5 greater than or equal to 0? Yes. So the absolute value of 5 is 5. Okay, how about the absolute value of minus 1.3? Okay, the absolute value of minus 1.3, of course, minus 1.3 is less than 0, so the absolute value of this number is going to be the negative of minus 1.3, which is 1.3. Alright, so this is actually how we calculate the absolute value of a specific mathematical number. Okay, alright, this is all what you need to know about absolute value. Now I'm going to talk about something called ratio. Okay, what do we mean by ratios? Alright, so let's talk about ratio now. What do we mean by ratio? Okay, now in order to understand the concept of ratio, okay, is actually related to something, or related to a number that is a proportion of another number. Okay, now suppose that we have, for example, okay, suppose that we have a number 10. Okay, the number 10, and this number 10 is going to be divided into 10 points. Okay, into 10 points. So we have, for example, all right, we have this 1 2 3 4 5 6 7 8 9 10. All right, okay, so in this case I have divided the number 10 into 10 individual parts, Okay, now if we look, for example, at this part of 10, we say that this part is actually 1 of 10. Okay, is actually one portion of 10. How about these two together? These two parts are considered to be, okay, or the proportion of these two is actually 2 of 10, right? It is 2 of 10. How about the 3? So this is a 3 to 10. All right, so ratio is the mathematical concept that is used in order to represent the proportions of numbers, or parts of numbers. All right, okay, now I'm going to give an example. Suppose that we have, okay, we have a number, for example, 1 divided by 2. All right, now this number can be read, or can be treated in several ways. We can treat it as, okay, a decimal point. So this number can be written in the form of a decimal number, such as, okay, which is 0.5. 0.5 is a decimal number which has the same value as 1 divided by 2, right? Also, 1 divided by 2 is considered to be a rational number, because we said that a rational number is a number that has a decimal point in it. Okay, so we have 0.5 is also considered to be a rational number. How about ratio? We also can read this number as a ratio of 1 to 2. 1 to 2. Okay, it is also expressed as 1 to 2. All right, this is actually ratio. Now if you would like to, all right, I will give an example in order for you to better understand the concept of ratios. Okay, all right, now I'm going to give this example. Suppose that we have this question, which is a simple question. Now, okay, suppose that we have this equation, which is x divided by divided by 49 is equal to 3 divided by 21. Okay, suppose that we have this equation. How can we calculate the value of x such that this equation is going to be satisfied? Okay, now in this case, if you would like to read this number, okay, you say that the ratio of x to 49 is the same as the ratio of 3 to 21, right? So this equation can be read in this way, in the form of ratios. Now, in order to calculate, there are several methods by which you can solve this equation. You have several methods by which you can solve this equation. One method is that you need to multiply. So we have x, all right? If we multiply both sides by 21, so if we multiply this by 21 and this by 21, okay, so in this case we have 21x divided by 49. This will give us what? These two numbers are going to cancel out, so this will give us the value of 3. And then we can multiply both sides by 49 divided by 21, multiplied by 21 divided by 49x. This will give us the value of what? 3 multiplied by 49 divided by 21. So we have multiplied both sides of the equation by the same rational number, which is 49 divided by 21. Okay, now in this case I will cancel out these two numbers, and these two numbers are going to cancel out, so this will give us the value of what? The value of x, which is 3 multiplied by 49 divided by 21. Okay, but we are not going to write this as the final value of x, because this rational number can be further simplified by the following. Now, if we divide the numerator and the denominator of this number by 3, it will give us what? So if I divide this by 3, this will be 1, right? And if I divide 21 by 3, it will give us the value of what? The value of 7. Okay, all right. Is this the simplest form of this rational number? No. Why? Because 49 divided by 7 will give us the value of what? 7. So this is the value of x that will satisfy this equation. All right? Okay, now, all right, now I'm going to talk about something called percentages. All right, something called percentages. And how can we deal with percentages? All right, so let's talk about percent. And what do we mean by percent? Okay, now we use the concept of percent. When we would like to, when we would like to talk about, for example, the proportion of 1 divided by 100. All right, 1 divided by 100. So the percent, if I multiply any real number by 1 divided by 100, 1/100th of x, this is called percent. Okay, this is called percent. So if I say, for example, 15%, okay, 15%, and this is the symbol, as you all know. This is the symbol that we use to represent the mathematical percent. Okay, 15% is actually equivalent to what? Is actually equivalent to the rational number 15 divided by 100. This is how we calculate the value of a specific percent. So if I want you to calculate the value of 15% of 15, what is 15%? 15% of 30, of the number 30. How can we calculate this number according to this definition? So in this case, I have to rewrite the percent in the form of a rational number, so 15 divided by 100, and this rational number should be multiplied by what? By 30. Okay, by 30. So in this case, this will give us what? Here 0 will be cancelled out. Okay, 15 divided by 3 is 45, divided by 10, which will give us the value of what? 4.5. So 4.5 is actually 15% of 30. Alright, this is how we calculate the value of percentages. Alright, okay. Now, okay, I'm going to talk about something called percent change. Alright, what do we mean by percent change or percent increase or decrease? Let's talk about this concept now. So sometimes, okay, sometimes we face, actually you should expect yourself to face a question that asks you to calculate the percentage change or the percent increase. So we are going to talk about percent increase or percent decrease. So we have percent increase. What do we mean by percent increase first? Okay. Now, suppose that we have a quantity, any quantity that you can think of. Okay, suppose that we have, for example, a group of balls. Okay, a group of balls. We have a group of 3 balls. 3 balls. Okay, and let's say that I am going to add one additional ball to this box or to this group every day. Okay, so every day I add one additional ball to the group of 3 balls. Suppose that this group in one day, all right, this group in one day is going to have the value of 10 balls. Okay, so let's say that I am going to have now, okay, let's say that I have added 7 additional balls to this box until it has reached the value of 10. So now I have a number of 10 balls in this box. Okay, now the question is, how or what is the percent increase? What is the percent increase? So I have increased the number of balls in the box until it has reached the value of 10. The question is how to calculate the percent increase in the number of balls. Alright, so in this case, I need to do this. I need to calculate the difference. So I have to calculate the difference between the two numbers. I have to calculate the number of additional balls that have been added to this group until it has reached the value of 10, which is actually 7. So in order to calculate the percent increase, the first thing we need to understand is to find the difference that has happened to the original number, which is 3. Okay, so in this case I have added 7 balls. 7 balls, so the percent increase. First of all, we need to calculate the difference, which is 7 balls. Alright, after that I have to divide this difference. I have to divide this difference by what? By the original number of balls, which is 3. So 7 divided by 3 multiplied by what? multiplied by 100. This is how we calculate, okay, this is how we calculate the value of what? Okay, the value or the percent increase. All right, in this case. So 7 divided by 3 multiplied by 100, which is 700, 700 divided by 3. Okay, this is the percent increase. This is the percent increase. Okay. Okay, how about if we have actually decreased the number of balls? So let's say that we have a group of 20 balls, 20 balls. So we have a box of